Hello and welcome to the Unit 3 review. This unit was all about solving equations. So let's go ahead and look at some of these and I'll give you an idea of what you want to do, but I'm not going to do them all as always. Okay? So starting off with the first one, or the first section, just says solve each equation, and that's just for the indicated variable. So let's look at a couple of these. Let's start with number 2. Again, I don't like to do all the easy ones for you, but just to give you an idea, in case you're stuck, you want to add 15 to both sides. Okay, and I'm expecting that you show your work if you want that full credit. So when you add 15, those cancel, and you're going to get 46. V equals 46 as your answer. Let's go ahead and skip down a ways. Let's go to number 6. Now, number 6 can either be seen as a one-step or a two-step equation. If you want to, you can say that it's 5/4 x equals negative 35. And you could either multiply 4 on both sides and then divide by 5 on both sides, or you can just say multiply it by its reciprocal and then figure out what that would be, because that's going to cancel out everything on the left side, leaving x. And then all you need is 35 divided by 4, or sorry, negative 35 times 4 divided by 5. And so we get x is negative 28. Okay, let's go ahead and look at number 10, and that'll be the last one we do on this page. On number 10, I'm kind of forced to multiply by 10 on both sides to start. So I get p minus 8. The 10's cancel. 1 times 10 is 10. Add 8. Looks like a nice little two-step equation there. And so p equals 18. Okay. Let's go ahead and turn the page and see what the next page looks like. Of course, just more solving equations, but they do get more complicated as we go. Let's go ahead and pick up on number 15. All right, number 15, it's a definitely multi-step equation with a variable on both sides. And we need to start with the distributive property right there. So let's write down what we have. We have negative 4a plus 7 times a, which is 7a, plus 7 times 2, which is 14. And that equals 10 plus 3a. So now we're going to go ahead and combine like terms of 3a plus 14 equals 10 plus 3a. Subtract the 3a from both sides. And it looks like this is one of those special cases. Now, does 14 equal 10? No, it does not. So that's a no solution. Okay, and we talked about those. So you should understand the difference between no solutions and infinitely many solutions. Let's go ahead and look down at the bottom. We have a couple, and there's more on the next page, but we have a couple of the literal equations where we're solving the equation for the indicated variable. Let's go ahead and look at the first one, 19. And here it says r equals d over t. Solve for t. So if I'm going to do that, I'm probably going to multiply by t on both sides. So we get tr equals d, because those cancel. And then divide by r. So t, when you divide, those cancel. T equals d over r. Remember, literal equations, you're going to have more variables involved, and you won't get a number as an answer. Okay? Let's turn the page, see what's coming up. So we have some more of the literal equations. Let's go ahead and do number 23. And for 23, we have this big, long equation here, and we want to solve it for h. Okay? So I want to get everything else on the other side. I'm going to start off because I have that 1/3. Oop, that's not a B, that's an H. Since I have that 1/3, I'm going to multiply by 3 on both sides to get rid of that. So that 1/3 cancels with that 3. So we have 3v equals pi r squared h. Since it's all multiplication on this side over here, I'm going to go ahead and divide by everything that's not h. So that's pi r squared. Divide by pi r squared. That cancels with that with that. We're left with h on the left side. I'm going to go ahead and bring it over to the right. So I have my h equals. And on the left side, this is what I'm left with. Or it's actually the right side now. So pi r squared. 3v over pi r squared. And that's my answer. Very good. Let's talk through the application problems real quick. On the first one, it says 372 students were on a field trip. The school brought 8 buses to take the kids to the field trip. 12 of the students went with their parents. So you want to write an equation to model that. So it might be something like, let's say we have number of buses times the number in each bus plus the number of students or of kids, let's go kids, that went with their parents. And that is all going to equal the total number, or the total kids. Okay? So one of those is going to be a variable. I'm going to say that it's going to be how many fit in each bus because the next one says how many students fit in each bus. So I'm going to say solve the equation that you just made. Okay. Now, of course, you're not necessarily writing this stuff. You're actually doing the problem. On number 2, the Swalk Rec Center charges non-members $16 a day to use the gym and $8 a day for a locker. Members pay a yearly fee of $450 for unlimited access to the gym and $6 a day for a locker. So write an equation to find how many times you must use the gym to justify being a member. Okay? And it says let your variable be the number of days as a hint. So I'm going to say that we will have so $8 per day for a locker and $16 a day to use it. So let's go with on the left side a non-member. If you're going to make it, if you're going to justify being a member, you're going to have non-member equal to a member. Because anything more than that, then you're definitely any more times you use it, you know that the membership is worth it. So on the left side, you're going to have $16 a day. So 16 times the number of days. And that's just to go in there. And then $8 per day. So then 8 times number of days. And that's for the locker. And then let's say that that's equal to the 450 plus the $6 times the number of days. All right, and when we do that, we're assuming that every day you go in there, you're going to use a locker. Okay? I understand that not all the times that you would go to the gym would you use a locker, but for this problem, we just assume that you do. And then the next part is just solve that equation. Let's look at the last one down here. And this is a nice little problem. The page for the NBHS Hesperia, that's your yearbook that you get, is 8.5 by 11 inches. The left margin is 3/4 of an inch. And the space to the right of the pictures is 2 and 7/8 inches. and then the space in between the pictures is 3/16 of an inch. So how wide can each picture be to fit 3 across the page? So let's say we have a page here, and it's gonna, since we're dealing with the width, I'm not gonna worry so much about the length. Okay, just to save a little bit of room and be able to make my picture a little bigger. So let's say we want 3 pictures. Okay, so let's say we have picture 1, picture 2, and picture 3. Okay, it talks about the left margin, so there to there, that's going to be 3/4. We don't know what the picture is going to be, but the space in between each picture is 3/16. So there to there will be 3/16. We don't know the picture, but there to there is another 3/16. Okay, and we don't know the picture. And then the space to the right is 2 7/8. So when you add all that stuff up, it's going to equal the entire width of the page, which is 8 1/2 inches. Okay, so you're going to have to put in variables for the question marks there, combine like terms, and then solve that equation for your variable. All right, so that's about it. Hopefully you guys enjoyed the video, or the little fun videos after the lectures, and good luck on the test that you got coming up. Make sure we're doing these reviews because they definitely help. But after this, we'll be on to our last section of first term, or last unit of first term. So congratulations, keep up the good work. We'll see you out there.